Hi guys, welcome to day 2 of our EOG math review packet. So we're going to go over the next 8 problems. So that'll be questions 9 through 16. Okay, so starting with number 9. There are 500 seats in a movie theater. There are 362 people sitting in the seats. How many seats are empty? So let's think about this. If I drew a bar model and this represents our whole theater, there are 500 seats in the whole theater. There are 362 people already sitting in seats, and we are trying to figure out how many seats are empty because there's either people in the seats or not, and they have to total 500. So remember, when we know our total, we don't want to add to it, because if you add 500 plus at least 300, that's already 800. And how can there be 800 empty seats when there's only 500 seats in the whole theater? So remember, you need to take the total, take out the number of seats that are full, and that's going to leave you with the empty seats. And remember, if you do it this way, that's fine. That's going to involve a lot of regrouping because you cannot take 2 ones if you don't have any, and you can't take 60 away from nothing. So remember the strategy I taught you to make an easier problem. If you take 1 away from each of these numbers, you're going to get the same answer you would if you did this subtraction problem. So if I take 1 away from 500, that gets me down to 499. And if I take 1 away from 362, that makes 361. And I'm going to get the same answer, but I don't have to do any regrouping. I can just subtract. So 9 minus 1 is 8. 90 minus 60 is 30. 400 minus 300 is 100. So there are going to be 138 empty seats, which means our answer is D. Okay, number 10. Which figure could be added to the diagram to make it true? And I know it's kind of hard to see, but this is a greater than symbol. And then this is which of these pictures would make this true. So this would be 2 out of 1, 2, 3, 4, 5, 6. So that figure has 2 sixths shaded. This area has to be greater than whichever of these you pick. Well, obviously, I'm looking at how much is shaded in this figure. That's almost the whole thing shaded. It's 1, 2, 3, 4, 5, 6 shaded. Well, is 2 sixths greater than 5 sixths? No. So that can't be the right answer. In this case, we have 1, 2, 3 sixths shaded. Well, is 2 sixths greater than 3 sixths? Nope. So we eliminate that one. Here I have 1, 2 out of 3, 4, 5, 6, 2 sixths. Well, is 2 sixths greater than 2 sixths? No, this would have to be the equal sign if that were correct. So that leaves us with A, 1 sixth. 2 sixths is greater than 1 sixth. So that's how you get the answer choice A. All right, number 11. Okay, Sam's goal is to walk 36 miles total. He walks 4 miles each day, and he has walked for 6 days. Which equation can be used to find how many more miles, and we're using an N for this number, Sam still needs to walk to reach his goal? Well, automatically up here, I'm thinking he walks 4 miles each day, and he's walked for 6 days. Okay, so 4 times 6. And I'm looking down here, and I see 2 answer choices that have 4 times 6 in it. Okay, so let's think about what else we are trying to find out. I know he needs to walk a total of 36, which all of them equal 36, so that doesn't help. But how many more miles, or n, means I'm going to figure out how many he's already walked by doing 4 times 6, and then I'm going to add n number of miles. That's how many more miles he needs to get in order to get 36. So this says 4 times 6 plus n number of miles would equal 36 total. This says 4 times 6 times n more miles. So the one out of those two that makes more sense would be B. 4 times 6 is what he's already walked, plus n more miles, we don't know, that's what we're trying to figure out, would equal a total of 36 miles. So that was why answer choice B is correct. Okay, number 12. Amy shaded some parts of this poster. What fraction of the area of the poster is shaded? Now, you might notice that we've got one shaded part over here and then a big shaded area over here. A good strategy to do is to create all equal parts so that can help you find the correct denominator or bottom number. So if you look at the size of these equal parts, you can kind of partition this larger shaded area into those equal parts. Kind of helps you visualize it easier. And you can see that those are all the same size. So now it's easier to count. How many total are shaded? 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8. And do I have an answer choice that says 5/8 shaded? I do. That's how we get answer choice D. Okay, 13. Eric leaves school at the time shown. So the first thing I want to do is read my clock here. And remember, the hour hand is the shorthand. It's past the 3, but it's not to the 4 yet. So it's still 3. And then I start at my 12 and count to my long hand, my minute hand. Count by 5s. 5, 10, 15. So Eric leaves school at the time shown. He leaves school at 3:15. He arrives home 25 minutes later. At what time does Eric get home? Well, because this is less than an hour, it's less than 60 minutes, there's a couple ways you can do that. If you have a picture of a clock like this, you can just count by 5s 25 more minutes and see where your minute hand is going to land. So our minute hand is pointing to the 3, and I count by 5s. 5, 10, 15, 20, 25. So that means this minute hand isn't crossing back over the 12, so it's still going to be 3 something. And if I'm landing here, I see what time is it if my minute hand is on the 8. And I count. If this is 15, 20, 25, 30, 35, 40. Okay? So I know my answer is C. And also, because you're only going 25 minutes, you can also, this is a time where this actually does work because, like I said, you're not going past the next hour. So that's why this works in this case. And if you add 15 plus 25 minutes, you get to 40. So you could do that strategy just for this problem. But if you have a clock, it's always sometimes good to just go ahead and use that picture to help you. Okay, number 14. Which number line shows point M at 3/8? So a good strategy to remember is to always think about what fractions are equivalent to half. So if we're talking about eighths, this says 1/2, but how many eighths is that equivalent to? Well, if you're thinking 4 is half of 8, or 4/8, you're exactly right. So a good strategy is to go ahead and label all of these halves 4/8. And the reason that helps is, if I know this is 4/8 and this is 6/8, I know this m has to be greater than 6/8. And I'm only looking for 3/8. Well, if this is 4/8, I know that 3/8 is going to have to be less. It's going to have to be on this side of the half. So that eliminates D, and it also eliminates C. A and B, both of these m's are less than 4/8, which is what we want. So now we just need to determine which one of those m's is at 3/8. So a strategy that might help you is to label all of the eights. So if this is 4/8 and this is 6/8, 5/8 must be here. So that means there must be an eighth in the middle here. And if this is 4/8, this must be 3/8. This must be 2/8. So can't be A. And now look again, if this is 6/8 and this is 4/8, this point would be 5/8. This point would be 3/8. So that is how they determine that B is the correct answer. Okay, number 15. Chantel has 56 stickers. She will give all the stickers to 8 friends. Each friend will receive the same number of stickers. Which equation will help Chantel decide how many stickers N to give to each friend? Well, when each friend is getting the same number, that forms equal groups. And equal groups are always either multiplication or division. So in this case, C and D are both subtraction problems, which means we are not using equal groups, so we can get rid of C and D. So now we think, if N is the number each friend gets, are you going to want to take the number each friend gets, divide it by 8? Are you going to wind up with 56? Is that reasonable? Or can you take 8 friends, give them each the same number, and it totals the 56 stickers? Okay, so hopefully you thought to yourself, B makes more sense there, because the number each friend gets is going to be smaller than 56. So you don't want to take a smaller number, divide it, which means you're putting it into equal groups, and then wind up with a big number like 56. That's just not reasonable for this problem. Okay, and last one, number 16. A farmer planted 5 different types of tomatoes. He planted 40 of each type. How many tomatoes did the farmer plant? So some of you, this might be obvious to you. Others, you might need to draw just a small picture. So if he's planting 5 different types of tomatoes, 1, 2, 3, 4, 5, and then he planted 40 of each of those types, and it wants to know how many total tomatoes did he plant. Some of you might be thinking addition, in which case you could add 40 plus 40 plus 40 plus 40 plus 40. But when you go to do that, hopefully your brain is thinking, wait, if I'm adding the same number repeatedly, then I can just do multiplication, because I'm adding 40 5 times. And hopefully when you see this problem, you remember the strategy of finding the basic fact, which would be 4 times 5. And if you count by 5s 4 times, 5, 10, 15, 20. you get 20, but remember it's 2010s, so it's actually 200. So he planted 200 total tomato plants. Okay, so that is your next 8. Hopefully that was helpful. I will be on here tomorrow with the next set of 8. So I hope that you all have a great afternoon. Bye.